of rational expression or rational function. So we will start with chapter 7.1 and work our way to 7.2. But before we work with the rational expression, let's define what the rational expression is. So the definition for rational expression is an expression that can be written in the form of P over Q, where P and Q are polynomial and Q cannot be equal to 0. So basically, rational expression is just the same as a fraction, ladies and gentlemen. You know, if we work with fraction 7 over 8, we say that is rational number. The only reason why we say rational expression is now the fraction that you have, the fraction that you are deal with, you will have some x variable or some y variable in it. Okay, so the example of rational expression is something like this, right? 3x squared minus 4 over 6, or x squared minus 81 over 3x plus 12, or x squared plus 11x plus 30 over x squared minus 4x minus 45. So those are your rational expression item. And again, the only thing that, like I mentioned, that we say that it's an expression is because we have some variable in it. If there's no variable, if I say 11 over 17, we say that is a rational number, right? So again, rational just basically tell you it's a fraction. And hopefully you guys see why is Q, why Q cannot be equal to 0, right? Why do they put this clock in here? Why Q cannot be equal to 0? So one thing is reminder, and later on you will see that if Q is equal to 0, meaning, for instance, if this thing here were to be equal to 0, and if 0 is on the denominator, reminder that if 0 is on the denominator, the whole item will be undefined. So the denominator cannot be equal to 0, because if it's equal to 0, the whole item will be undefined. So in our case, whatever Q, as you can see, 6, 3x plus 12, x squared minus 4x minus 45, as long as those item is not equal to 0, we are good to go. Okay, so our item is not to identify if it's a rational expression or not. Our first item, or the first thing that we need to do, is we need to simplify your rational expression. And to simplify your rational expression is basically to reduce the item in the lowest term. So basically, if you were to take a look at this item, and for instance, if we don't have an x, if we don't have an x to the 4 and x to the third, if let's say that my problem or your problem, let's say your problem is only 28, not 28, 18 over 27. And this is the problem we have prior. What do we do if we have 18 over 27? Well, basically, I told you that if we have 18 over 27, if it's a fraction, we need to reduce the fraction. And to reduce the fraction is basically you have to ask yourself, what is the common divisor? And then you just divide the numerator by the same number as you divide by the denominator, right? So basically, if you look at this thing here and you say 3 is good. 3 is a good number. 3 can go to 18 and 3 can go in 27, but 9 is better, right? 9 can go into 18 and 9 can go in 27. So in the sense, this is what we do in here is, ladies and gentlemen, we have a rational expression. And like I mentioned, the rational expression is basically because we have an x. So in the sense, this is all they ask you to do is, can you break the numerator? Can you break the numerator in terms of a multiplication? Do you agree that 18 is the same as 9 times 2? 9 times 2 is 18. And do you agree that x squared times x squared will give me x to the 4? If you go back to chapter 5, when we multiply the base with a different exponent, we add the exponent. So all I did was I break down my numerator and I break down my denominator. Instead of write 27, 9 times 3 is 27. So this is all that you're going to do here, ladies and gentlemen, is break down your numerator, break down your denominator, and ask yourself, what do we have the same on the top as on the bottom so that we can cancel out? And that is what we're going to do. That is the chapter 7.1 and 7.2 is all about. You will say, whoa, that is very easy. Yes, that's all that is how can you break down the numerator? How can you break down the denominator so that you have something the same on the numerator as over the denominator? Because do you agree that 9 over 9, we cancel it out, but 9 over 9 is technically equal to 1. X squared over x squared technically is equal to 1. They cancel out or is equal to 1. So what am I left with? Well, I left on the numerator, I left with a 2. I still have x squared. I only cancel out x squared. And on the denominator, I have 3. So that is the only thing in chapter 7.1 or section 7.1 and section 7.2, as you will see. You will say, wow, that's easy. And again, like I mentioned, is that easy? Is that, you know, I'll go, nothing new. We did this before. It's just that now they apply of what you learn to the problem that you learned prior. It just basically they combine everything you learned before and put in one problem. And looking at B, same thing go. Looking at B, you basically ask yourself, do we have a common divider between 24 and 33? Hopefully you say that 3, right? 3 can go to 33 11 times, and 3 can go to 24 8 times, right? Between an x, how much or what can I break down? So as you can see on the numerator, again, this is what I break down. Instead of write 24, I just say 8 times 3, because 8 times 3 is 24. Instead of say 33, I just say 11 times 3. And on the top, instead of say x to the 5th, I just say, well, I have x squared on the bottom, so let me break it down, x squared times x to the 3rd, because 2 plus 3, that will give me 5. And on the bottom, instead of write y to the 7, I can break it down in terms of 3 plus 4 will give me 7, right? So instead of multiply in chapter 5, we kind of factor them out. It's just that we don't put an outside the parenthesis. I mean, we could technically put it outside the parenthesis, but basically we break it down. Basically, it's the same as you factor them out. And now the only thing new, right? This is the only thing new is you say, well, the 3 on top and the 3 on bottom, we can cancel them. The x to the 2nd on top and the x on the 2nd to the bottom, we can cancel them. And again, the y to the 3rd on top and the y to the 3rd on the bottom, we can cancel them out. Or in the same, they are the same, so we can cancel that out. And if we can cancel that out, what is left? I have 8 to the 3rd on top over 11 y to the 4 on the bottom. So that's what we have in our problem. Is we last time in chapter 6, we just factor them out, we break them down, and we kept it. Now in chapter 7, we break them down, but because they are in a fraction form, if they are the same, we cancel them out, or we eliminate them because they are the same on the numerator as the same on the denominator. Okay, so let me pause and let me ask you guys in terms of A and B, question with A or B here. Question in terms of how I got the answer in A or how I have the answer in B, ax to the 3rd over 11x to the y to the 4. So if you don't have question in A and B where you have a binomial over a binomial, and I forgot to mention this thing here is, if you have a binomial over binomial, you can pick and choose. As you can see right here, A and B, I can pick and choose in terms of what I can cancel out. Now in C, if you look at C, if we have a binomial, and how do we know if a binomial versus a binomial? Well, if your items separate by addition or subtraction, we know that it's a binomial, right? And again, up here, this item is we have a trinomial over a trinomial. So one thing is, if we have a binomial over a binomial, you can pick and choose what you can cancel or what to cancel out, right? If you have a binomial over binomial, the 3 over 3, you can cancel them. The x squared over x squared, you can cancel them out. And vice versa, the y to the third over y to the third, you can cancel them out. But if you have a binomial over a binomial, if you have a binomial over a binomial, you cannot pick and choose. Meaning you cannot say, oh, the 4 and the 10, I can cancel them out. You cannot pick and choose and cancel, because in order for you to cancel the binomial, ladies and gentlemen, in order for you to cancel a binomial or a trinomial, they need to be exactly the same. Okay, in order for you to cancel them out, whatever you want to cancel them out, they have to be exactly the same. If they are not the same, you cannot cancel them out. So in this case, we cannot pick and choose what we can cancel. In order for you to cancel, you need to see them exactly the same. So how can we simplify this expression? Just like before, in order for you to simplify, this is what I tell my student is, imagine your numerator as one problem and your denominator as one problem. In the numerator, what can you factor them out? So between the 10 and the 34, do you agree between the 10 and the 34, they have a common divider of 2? Because 2 times 5 is 10 and 2 times 17 is 34. And between on the denominator, between the 4 and the 8, what is the common divider? What can you factor out? What is the GCF? The GCF, once again, is a 2, because 2 times 2 is 4 and 2 times 9 is 8. And as you can see, we haven't done anything new, because that's what we did in chapter 6. We factor out a GCF. It's just that now they double stack your problem, right? The test you took last night, you only have one, either the numerator by itself or the denominator by itself. And they ask you to factor out a GCF. Now they double stack the two problems, they put one on top of another, and they tell you if you can factor them out, and if they are the same, you cancel them out. Okay, and that's all there is if you can factor them out, and if they are the same as on the numerator, as the same as on the denominator, you cross them out, they eliminate each other, or is equal to 1. Okay, so that's my answer. Even though it is look very, not what you're looking for, but this is the answer we have. 5x plus 7 over 2y minus 9. All right. Now, you might have a question, but let's go over D, and then I will take your question, and then we can go back to C if you have the item. So looking at this thing here, like I mentioned to you guys, hopefully you guys say that, oh, this is a binomial x plus 4. This is a binomial 5x plus 20. I cannot pick and choose. I cannot say, oh, the x and the x, oh, Mr. Trent, x and x cancel out 5 plus 20, 25. My answer is 4 over 25. We cannot do that. In order for you to cancel out the binomial, they need to be exactly the same. If you want to cancel the x, you have to find another plus 4. You have to cancel the whole item. You cannot pick one item and cancel not the other one. Okay, so this is what I tell my student is, imagine you have two problems, one on the numerator, one on the denominator. In the numerator, can you factor anything out? X plus 4, well, x plus 4, I cannot factor anything out. X plus 4 is just x plus 4, they don't have a GCF. But on the denominator, do you agree that on the denominator, 5x plus 20, I can take out a 5. And if I can take out a 5, do you agree that this is what I have? And let me write it this way. Do you agree that this is what I have is on the denominator, I have 5 because 5 times x is 5x and 5 times 4 is 20. And this is what you have, ladies and gentlemen. Do you agree that on the numerator, I have x plus 4? On the denominator, I have x plus 4. Again, this is the only thing new, believe it or not. This is the only thing new in chapter 7.1. Is they tell you that on the numerator, you have something the same as the denominator, cross them out. And if we can cross them out, what do we have? Well, we still have the phi on the denominator. But to illustrate that the phi is on the denominator, we have to put the 1 on the numerator to say that it's 1 over phi. Remember, 1 over phi is not the same. It's not equal to phi. Okay, so 1 over phi is not equal to phi. Phi, you want to have $5, but you don't want a fifth of a dollar, right? So again, a fifth of a dollar is just 20 cents. Yes, I know that based on the money, you want $5, but because the phi is on the denominator, you have to illustrate that it's on the denominator. So in this case right here, this is your answer. Once you have them the same, right? This is the two answers we have. Your goal is how can you take this problem? How can you take this problem right here and simplify them to this answer that you have right here? Okay, so let me ask you this question here. Let me ask you this question, or let me ask you, do you have any question? How can you take that problem and get to this answer here? And again, we did not, the problem looked new, the problem looked different, but we haven't done anything out of the ordinary, like brand new. We haven't done anything new, ladies and gentlemen. And I know you say, oh, it's look new, but again, we break it down in terms of the basic, right? They give us this massive problem. If you don't have questions, let's take a look at this thing here. Well, we will go back in a bit. They basically, let's go back. They basically give you this massive problem, but no matter how massive a problem is, we break down to something we know, and that's what you want to do. That's what you want to, attack this problem that way. Okay, so we will go back and simplify this item a bit. But before we do that, the next thing that they will ask you is, if we give you the problem, if we give you a problem, can you identify the undefined value? So if you remember what I mentioned earlier, how can you find the undefined value, or how can your expression be undefined, right? How can this item be undefined? Well, there are 3 scenarios, or this is what you need to do, is if the denominator do not have any variable x, y, or z, if they don't have any variable, then you don't have an undefined value, okay? If your denominator do not have a letter underneath it or on it, in it, it does not contain any undefined. If your denominator do contain any variable, how do you find the undefined value? This is all you need to do, is you extract the denominator out and set it equal to 0. That is your item here. If there's no number, if there's no variable, for instance, if we look at this example 2a, if there's no variable, doesn't matter what the numerator is, doesn't matter what the numerator, I don't care about the numerator. The numerator can be 1,000,000, I don't care. Because in order to be undefined, the denominator have to be equal to 0. So my first option is, in this case, this item right here, the 9 does not have an x, so there is no undefined value, right? This thing here, the answer will be no undefined value or real number. Now, what happens if your denominator have an x, right? In this case, like I say, we don't care about the numerator, ladies and gentlemen. We only care about the denominator, and in this case, the denominator have an x. So what do we do? This is all you need to do is you take this denominator and you extract them out. We take this denominator and we set it equal to 0. Whatever the denominator, I don't care. I take the denominator and set it equal to 0. Once you set it equal to 0, can you solve for x here? Do you agree that you can solve for x here? And how do you solve for x? Well, if you have x minus 5, do you agree that you need to plus 5 on this side? And if you plus 5 on one side, you need to plus 5 on the other side, right? Because -5 and +5, they cancel out. And if they cancel out, what do we have? Well, the answer will be x is equal to 5. Because if I subtract, if I add on this side, I need to add on the other side. So this number right here, this number x equal to 5, that is your undefined value. Why is undefined value? Because if you were to plug it in here, if you were to plug it back in there, everybody see that 5 minus 5 is equal to 0. And what is 121 divided by 0? Well, 121 cannot divide by 0 because 121 divided by 0, that will be undefined. Okay, so the idea here is if we have an expression, how can you identify the undefined value? So if there's no value on the, if there's no variable on the denominator, there's no undefined value. If there's a variable on the denominator, all you do is take that denominator and set it equal to 0. Similarly, with C, all we do is we take this denominator and we extract them out. So 3x plus 17, we extract them out and take the 3x plus 17 and set it equal to 0. What do we do from here? Do you see that all we need to do is to solve for x? How do you solve for x? Well, hopefully you guys say, I need to subtract the 17 to that side, right? I need to subtract the 17 on that side. Well, this side, so I need to subtract the 17 on that side. The 17 and the negative 17, they cancel out. And this is what I have. I subtract the 17 to give me 3x all equal to negative 17. And now how do I get rid of the 3? You tell me that we need to divide it by 3. And if I divide by 3 on both sides, I have negative 17 over 3. And that's my answer. My answer meaning if this number, if I plug it in here, they will be undefined or they will be equal to 0. And the denominator, if the denominator equal to 0, the whole thing is undefined. And again, you will say, what, Mr. Tran, I'm confused about the y. Don't worry about this y. In order to be undefined, we only care about the denominator. Doesn't matter what the numerator is. We only care about the denominator because the numerator do not make the expression undefined. So we don't care about that negative y, right? Because negative y, whatever on the numerator, it can be that you want it to be, that's fine. But if it's over 0, then it's undefined. Okay. So first of all, question with A, B, or C, how to find the undefined value. Now, here comes the problem that you will see a lot, ladies and gentlemen. This is the typical problem that you will see a lot. And again, the example, they still ask you, find a number, find any number in which you plug into this expression, rational expression, and that make this item undefined, or basically find the undefined value. So looking at this thing here, do you agree that this is my denominator? So what do? I just take this denominator and set it equal to 0. So if we clear this thing out, right? If we clear this thing out, how do you solve for x here? How do you solve for x, or what is the difference between this problem versus the previous 3 problem? Well, the previous three problems, they don't have a square. And what do we know, or what do you know? If you took the test last night, you know that if there's a square and it's equal to 0, well, we need to factor it out, right? In order for us to solve this problem, we need to factor them, which is 6.6. How do you solve by factor? So we have a square equal to 0. We need to factor. And if you look at this particular problem, is this an easy problem or a hard problem, right? And if you took the test last night, hopefully you say that this is an easy problem. How easy? Why is easy? Because there is no number in front of x squared. There's no number in front of x squared, or technically the number in front of x squared is equal to 1, right? So looking at this problem, is it anything new? Well, no, right? To solve for this thing here, we need to factor, and to factor this thing here, we need to open two parentheses and ask ourselves, is there a number multiplied to give me 21, but subtract to give me 4? And in this case, you can see that 7 times 3 is 21. 7 minus 3 is 4. And because we subtract them, one of them will be positive and one of them will be negative, which in this case, the bigger number will get the sign of the meter term. So you have a -4 and a +3. We are not done, because that is your factor. To find the answer, you need to take x minus 7, set it equal to 0, x plus 3, set it equal to 0, and solve for x. To solve for x, you have to add 7 to both sides, and you have to subtract 3 on both sides. So the two answers you have will be 7 and -3. And again, that is why I told you chapter 7 is hard, is because we have trouble with factor. If you don't have trouble with factoring, chapter 7 is not hard at all. Okay, and I'm not, I'm not saying it to say it, because all this thing here is what we did on the previous test, right? The only thing new is they put it in a different form that we haven't seen, right? They put in a rational expression. So let's try put the two items together, right? Or let's do this one here. I thought I have let's do another one to show you what is the step and how to find the undefined value. So looking at this item here, I don't care about the numerator. In order for me to find the undefined value, I take the denominator and I set it equal to 0. All I did was I take whatever the denominator is and I set it equal to 0. So if you did that, and again, if you did that, let's forget about this item. Forget about this item. This is your new, or this is the problem that we're looking at. Okay. So how do we solve this problem? What do we need to do? Well, we have an x squared. So we know that we are, we have an x squared and there is something equal to 0. We know that we need to factor them out. That's the only thing we learned before, is to factor them out whenever we encounter an x squared. So in this case, we have an x squared, so we need to factor this thing out. Now, is this a hard problem or an easy problem? Hopefully you say it's a hard problem. Why there's a hard problem? Because there's a 3 in front of the x squared, and because there's a 3 in front of x squared and I cannot get rid of it. And if I cannot get rid of it, meaning I have to do the AC method. What does the AC method do? Well, the AC method tell me take the 3 times the 8, 3 times the 8, which is the A and the C, to give me 24. Now I need to ask myself, is there two numbers multiplied to give me 24, but add together to give me 10? So again, 24, 4 times 6 is 24, or in this case, I have 6 times 4 is 24, and 6 plus 4 will give me 10. what do I need to do? Instead of write the problem 10x, I just put in the 6x and the 4x, because 6x plus 4x eventually equal to 10x. And again, as you can see, what do we need to do after you rewrite problem? You need to group them up. And if you group them up, this is what you have. You put the two number in the first group, you put the two number in the second group. And in the first group, between the 3 and the 6, I can factor out a 3. 3 going to 3 one time and 3 going 6 2. Between a 4 and an 8, I can take out a 4. And I still have x minus x plus 2. And x plus 2 and x plus 2, I bring it to the outside. What is the leftover? The leftover is 3x plus 4. Again, all of this item, ladies and gentlemen, all of this thing on your screen, we did this before, right? We did this 2 weeks in a row, right? So is this new? Hopefully not, right? This is not new. This is whatever we did right here is we do the AC method and then we factor with AC, right? And again, what do we do here? Which the only thing we're doing is we're still not done because it's equal to 0. We have to say x plus 2 equal to 0, 3x plus 4 equal to 0. And how do I solve for x? Well, I subtract 2 to give me x equal to -2. I subtract 4 to give me -4 over 3. So those are the two values that is undefined, that make this item undefined. Okay, so I keep on saying this, but the material that we're doing, all of this item right here, if you look at all of this step, all of this procedure, we did this prior. This is nothing new, right? The only thing new is they give you this format. The only thing new is they give you this format rather than give you this format, right? This is what we did earlier. This is what we did in chapter, the red item right here. This is what we did in chapter 6. In chapter 7, instead of giving you this problem, they give you this format so that you can see, or so that you need to see that you take the denominator and set it equal to 0. Okay, so let me ask you guys, in terms of in terms of this problem that I have over here, question on how we start, and question on how I got the answer. Any question here, ladies and gentlemen? All right. So now, example 3, I thought I have this, but earlier, but example 3, this is where they put everything together. They put example 1 with example 2 together to give you this example 3. So they ask you this question is, first you have to find any number that give this item undefined. And then secondly, you need to simplify, meaning reduce your rational expression if possible, meaning reduce it to the lowest term. Okay, so let's do the first item. How do we know, or how do we find the undefined value? Well, to find the undefined value, everybody agree that all we need to do is take the denominator, x squared minus 64, take the denominator and set it equal to 0. This is my denominator, x squared minus 64. I take this item, I set it equal to 0. And if you take x squared minus 64 equal to 0, hopefully, hopefully you say, x squared minus another perfect square. How do you solve for x when you have x squared? Do you agree that x squared is the same as x minus 8, x plus 8 equal to 0? This is a perfect binomial, right? The difference of the square. And once you factor them out, the two answers you have is x equal to 8 and x equal to -8, meaning those are the two numbers you plug into this item, and this item will be undefined, right? That's your undefined value, x equal to 8 and x equal to -8, okay? So that's the first item they ask us to do, is find the undefined value. And since there's a variable underneath or the variable in the denominator, those are the two variable, or those are the two number that make this thing here undefined. Now, how do we simplify this item? Well, to simplify this item, this is what I tell my student is, ladies and gentlemen, just treat your numerator and your denominator as two separate problems, okay? Just treat your numerator as one problem. So let's forget about this thing for now. Let's take a look at, let's focus on here. Can you factor anything out? Right? That's the question you need to ask yourself, is on my numerator, can I factor this thing out? Is there a common item, or is there a GCF? And hopefully you say, yes, Mr. Tran, the 4 and an X, right? 4 can go to 4 one time, and 4 can go 32 8 times. There's an X squared here, and there's an X here. They have a common X. I took it out. If I took it out, X squared minus X, I still have 1. There's no more X, right? My common item is there's a 4 and there's an X. So that's what we do, is we treat the numerator as one problem. And now we treat the denominator as another problem, which is forget about the numerator. Can we factor this out? Well, we did that, right? We did that. We factor x squared minus 64. We factored it out, x minus 8, x plus 8, right? We factored that out. So as you can see, at this particular step right here, have I done anything new? No. All I did was factor the numerator and factor the denominator, okay? Now, what is new in chapter 7? Well, the only thing new in chapter 7 beside the undefined value is they tell you, hey, x minus a on top and x minus a on the bottom, they all look the same. And if they are the same, I can cancel them out. I can cross them out. And if I cross this thing out, the numerator, I still have 4x. And the denominator, I have x plus 8, and that will be my answer. And again, reminder, ladies and gentlemen, the 4 and the 8, do not impress me the wrong way. This 4 and this 8, you cannot cancel them out, because on the numerator is a binomial, and on the denominator is a binomial. Remember, in order for you to cancel out the binomial, you need to have exactly the same. If they are not exactly the same, you cannot cancel them out. You cannot pick and choose and cancel what you want to cancel if you deal with a binomial or a trinomial or a polynomial. In order for you to cancel out a binomial, trinomial, or polynomial, they need to be exactly the same, okay? Let's try one more, and then I take your question. And I want to show you that, you know, the problem now in chapter 7, and when you take your test on chapter 7, this is your problem. You have x squared minus x minus 42 all over x squared plus 3x minus 70. So if you look at this thing here, just like I mentioned in the beginning, the only thing different in chapter 7 is instead of give you one problem by itself, they give you two problems and stack them on top of each other. So let's go over how do I find the undefined value. To find the undefined value, I need to take the denominator. I need to take the denominator, which is x squared plus 3x minus 70, and set that equal to 0. And because I have an x squared and equal to 0, in order for me to solve, I need to factor them out. And by now, hopefully you see that 10 times 7 is 70. 10 multiplied to 7 is 70, and 10 minus 7 is 3. And because we minus, one of them is positive, one of them is negative. And because the 10 is bigger, the 10 will take the sign of the meter term. That is your factor. But your answer is x got to be equal to negative 10 and x is equal to negative 7. Those are the two values that make your expression undefined. Meaning if you plug in negative 10 or if you plug into 7, the denominator becomes 0, and the denominator becomes 0 is become undefined. Okay, so in order for you to find the undefined value, you need to take the denominator and set it equal to 0. That's your first item. Now, how do we simplify? How do we simplify our expression? How do we simplify this thing here? Well, to simplify this, this is what you need to do is we treat the numerator as one problem. We treat the denominator as another problem. Just treat the numerator separately and treat the denominator separately. So basically, I tell you guys is you just have two factoring problem together. Okay, and when we get to 7.2, if we're able to get to 7.2, instead of two factoring problem together, we have four factoring problem together. Okay, so now let's take a look at 1. Do you agree that at 1 or on the numerator, x squared minus x minus 42, is there two numbers multiplied together to give me 42, but subtract to give me 1x, right? This is if there's no number in front of the x, it's assumed to be 1. Do you agree that we factor them out by putting x? And negative 7 times 6 to give me negative 42. And again, why is negative 7? Because the bigger number will get the sign of the meter term. So on the numerator, that is my factor. My factor is x minus 7, x plus 6. On the denominator, we factor the denominator already. The denominator is x plus 10, x minus 7. So, you know, the problem is solved. The problem is solved. I agree with you 100%. The problem is solved is look different, but the concept or how we derive to our answer is just what we've been doing. Is we factor them out, and in chapter 7, they tell us that because we have x minus 7 on the numerator and because we have x minus 7 on the denominator, that two items can cancel them out. And if you can cancel those out, what is left over? The leftover is x plus 6, x plus 6, and x over x plus 10. And once again, this x and this x, you cannot cancel them. You cannot cancel this by 2 because there is a binomial. In order for you to cancel, you have to cancel the whole thing, like this one here and this one here. They have to look exactly the same. If they're not exactly the same, that will be my answer. That is how you simplify your rational expression. So let me pause a bit and let me ask you guys question in A or question in B, how to find your undefined value or how to simplify your rational expression. Any question here, ladies and gentlemen? All right, let's take a look at a few more. Let's take a look at C. Same idea go, right? This is what we have in C, x squared minus 81 all over x squared minus 7x minus 18. So looking at this thing here, hopefully you guys see that in order for you to do the undefined, in order for you to do the undefined value, all we need to do is take the denominator, x squared minus 7x minus 18, we set it equal to 0. Okay, to find the undefined value, we extract the denominator, set it equal to 0. And to solve for this thing here, we need to factor out. Is there two numbers multiplied to give you 18, but subtract to give you 7? Is there two numbers multiplied to give me 18, but subtract to give me 7? And hopefully you say, yes, there is a 9 and there is a 2. 9 times 2 is 18, and 9 subtract 2 will give me 7. And which one is positive, which one is negative? The bigger number will get the sign of the meter tone. We factor it out. Now, how do I solve for x? To solve for x, we need to take x minus 9, set it equal to 0. X plus 2, set it equal to 0. And once you have this item here, what do? Well, we add 9 to give me x equal to 9. We subtract 2 to give me x equal to -2. Those are the two numbers that make this thing undefined. Those are the two numbers that make this item undefined. So the two values that make this item undefined is 9 and -2. Now, how do I simplify? Just like before, all you ask yourself is, we have one problem and two problems. Again, I just wrote the 1 and the 2 just to show you that we treat the numerator as one problem and we treat the denominator as another problem. So in this case, can we factor the numerator? Can we factor x squared minus 81? And again, hopefully you say, yes, x squared minus 81 is a perfect square. And if it's a perfect square, I put x and 9, one parenthesis, x and 9 on the other one, and they have a one positive and one negative. And on the bottom, again, on the bottom, we did it on the numerator, denominator, we did it, right? X minus 9, x plus 2. It's the same problem we have up here. So again, question on how I derive from this particular item right here, x squared minus 81, x squared minus 7 over 18 to this problem here. Question on how did I convert from this yellow box to become this yellow box here? Because the new item is not really new, right? The new item come in is tell you, x minus 9 on top, x minus 9 on the bottom, they equal to 1, they can cancel out. And this is your answer. That's the, all of this, all of this thing here, the only thing new is this red dot, right? This red line is just tell you, and it's not really new, right? It's just a concept we've been using before. It's just that now we adapt to this problem where some of you guys say, oh man, it's complicated because you stuck with how to factor. Okay, so that's why we kind of spend a lot of time on chapter 6, because I want, and hopefully that you can factor, because like I mentioned, without know how to factor, chapter 6 is impossible to do. And now without knowing how to factor, chapter 7 is you will see is just out of this world. Okay, so we have to, if you have not done so, get to review your factor rule. Look over your factor item. Okay, and again, let's take a look at 7.2, and I want to, we can do the beginning of 7.2 to show you how, what is the relationship between 7.2 versus 7.1. So 7.2 is we need to multiply and divide rational expression. And to multiply and divide, this is what I tell my student, or this is what I want to tell you guys is, before you can multiply or divide, ask yourself, can you break it down and cancel them out? can you factor it out and cancel them out? Okay. And like I mentioned earlier, instead of just two problems, like in 7.1, instead of two problems, the numerator over the denominator, now we have four problems. We have one item here. No, to illustrate to you with D, we have one problem here, one problem here, one problem here, and one problem here. So basically, like I mentioned, instead of two problems, in 7.2, we just have four different problems. Okay, that's what you want to look at it, is we have four, one big problem is just the combination of four small problems together. Instead of give you one by one, they stack them all together and put it in this item. So one thing in chapter 7 is, before you can multiply, ask yourself, can you break them down? Can you factor them out so that you can multiply? So let's take a look at A. And this is what you ask yourself is, in the first item, in this item here, 6, can I break it down to some multiple? And hopefully you guys see that 6, we can break it down to 3 times 2. And can I break down any x? As you can see, the x is just x. We cannot break it down. For x squared, what can I do? Well, x squared, I can break it down to x times x. And 22, I can break it down to 11 times 2. So basically, at each location, the idea or the goal is you want to ask yourself, can you break it down? And looking at this thing here, remember, if they don't have an addition or a subtraction, then it's still just a binomial. And if it's a binomial, this is what you want to do is, binomial, you can cancel out vertically or diagonally. Never, ever, ever cancel out horizontally. So you just ask yourself, do I have anything diagonally or vertically so that I can cancel them out? And in this case, as you can see, the 2 and the 2 diagonally, one on top and one on the bottom, I can cancel that out. The x diagonally, one on top and one on bottom, I can cancel that out. And if you can cancel that out, meaning they are equal to 1, what do you have on the numerator? On the numerator, I have a 3 left. And on the denominator, I have the 11 and the x. So 3 over 11x, that would be my answer. Okay. So again, all we're doing is, even though they say we multiply and divide, all we're doing is we try to break it down to a smaller number, so that instead of multiply a big number, we just multiply a smaller number. So we want to cancel them out first, make the problem smaller, and then put them together, meaning multiply them. So let's take a look at B. And like I mentioned, B, we have one problem here, we have 2 problems here, 3 problems, and 4 different problems. So at the first item, do you agree that 2x is just 2x? At the second item, x squared minus 5, what can you factor out? Well, between the x squared minus 5, this is a binomial. We can take out an x because there's an x squared and there's an x. I can take out an x, left me with x minus 5. At 3x minus 15, well, 3x minus 15, I can take out a 3 because 3 can go in 3 and 3 can go in 15. And lastly, at the 34, I can write it at 2 times 17. And once I do that, you can see that the 2 and the 2 diagonally, we can cancel them out. They look exactly the same. The x and the x, we can cancel them out. And also the x minus 5 and the x minus 5, we can cancel them out. Okay, so again, that's what we have is we either cancel out diagonally or we can cancel out vertically. The x on top and the x on the bottom, we can cancel them out. And again, x minus 5, they are the same. We can cancel them out. And if we can cancel everything else, what is left? The only thing left we have is 3 over 17. And again, let me pause and ask you guys question with A or question with B. Now, let's take a look at C. Same idea, same concept, right? Let me erase this. And like I keep on mentioning, the first two problem, I did not do this, but again, this is what I told you guys. Just imagine that this problem, you have 4 different problems. You have x squared minus 36, 7x plus 42, 2x squared plus 8x, and x squared minus 2x minus 24. This, ladies and gentlemen, each of them, imagine that they are their own separate problem. So at the number 1 here, x squared minus 36, hopefully you say, oh, that is a perfect square, Mr. Tran. And if it's a perfect square, you have x minus 6, x plus 6. That's how you factor a perfect binomial, right? And now at 2, what do we have? Well, 7x plus 42, what can you factor out? Well, is there a GCF? And in this case, the 7 is a GCF. 7 can go to 7 and 7 can go 42. And at 3, what do we have? Well, we can factor out a 2 and also an x, right? 2 going to 2 one time, 2 going 8 4 time, and x going x squared is x time. The x, we take it out, there's no longer an x. And at 3, hopefully you guys see that 6 times 4 is negative 24, and 6 minus 4 is 2. So because it's minus, one of them is positive, one of them is negative. The 6 is negative because the bigger number get the sign of the middle term. So this is what we did, ladies and gentlemen. We convert this problem. Well, we're not really convert them. We just basically factor each individual item. We take this thing here and we treat them as 4 different factoring problems. And again, yes, I agree with you guys. It's tedious, it's massive, all of the above, right? But it's not new. The look of the problem is new, but the actual problem itself is not new if you break it down in terms of each individual problem. Okay, and again, I know I was there, and again, I know that some of you probably take the whole page. Some of you probably take the whole page to do this problem, and that's what it takes. The whole page, because there are 4 different problems in one, right? And this is the new thing that we have. The new thing which we have is this, ladies and gentlemen, is x plus 6 on top and x plus 6 on the bottom. We can cancel them out. X minus 6 on top, x minus 6 on the bottom, we can cancel them out. X plus 4 on top, x plus 4 on the bottom, we can cancel them out. So again, that is the only thing new, believe it or not. If we can cancel them out, what do we have? Which is the top number, I still have 2x, and the bottom number, I have 7. So my answer is 2x over 7. Okay. And again, question here, ladies and gentlemen, please, if you have question, I will hopefully can help you to find the solution so that you can do your homework, and because the problem will not get any newer. This is the basic of chapter 7 is this, and they just add on. Question here in terms of C. All right, let's take a look at D. If you don't know what to ask, hopefully after D is either a little bit clearer, or is give you something to ask, right? So if you take a look at this thing here, if you look at D, same idea go, right? To simplify this thing here, they don't ask you for undefined, they ask you to multiply to multiply this thing here, just imagine that you have 4 different problems. And at one, how do you factor at 1? To factor 1, we ask ourselves, is there 2 numbers multiplied to give me 56, but subtract to give me 1? So what do I have? I have -8 times 7, because 8 times 7 is 56. 8 minus 7 will give me 1, but because it's minus, I need to have one of them. The bigger number will get the side of the meter term, right, at 1. At 2, what do I have? Well, is there 2 numbers multiplied to give me 64, but add together to give me -16, which -8 times -8, -8 times -8 will give me positive 64. -8 and -8 will give me a -16. At 3, what do we have? Well, at 3, there's nothing we can do except that they have a GCF, and in this case, the GCF is the x. They have an x squared and the x. What you can do is you can take out x, and this is what you have. And at 4, this is the tedious part. At 4, this is the AC method, because there's no way you can get rid of 4, because 4 cannot go in 45 and 4 cannot go in 21. So what do? We take the 4 multiplied to the 21 to give you 84. Is there 2 numbers multiplied to give you 84, but subtract to give you 25, which 28 and 3? We rewrite a problem, we group them up, and we factor out by grouping. And that's what we have to do at 4. And 4 is probably the hardest problem you have, in the sense that because it's an AC method, and some of you guys still have problem with that AC method. But again, what we just did was we factor out 4 individual items, and then we put it back to our problem. Instead, write x squared minus x minus 56. I just say, well, this is the new factor, x minus 8, x plus 7. And again, the rest is the same. So we factor that item out. Now, what do we do? Well, all we need to do is, what do we have in common? We have x minus 8 on top and x minus 8 on the bottom. One of them, so I can only cancel out one of them. X plus 7, 4x minus 3, 4x minus 3. So those are the items that they have on same on top as same on the bottom. So again, I can cancel this out, I can cancel this out, and I can cancel this out. Now, if I cancel those out, what do I have? Well, the only thing I have left is x over x minus 8, which in this case, this is what we have, x over x minus 8. And again, let me ask you guys question here. Question in how to begin and how your answer should look like.